Hello, welcome. This is Investing Your Money, Arithmetic, Geometric, or neither. I'll read you the problem, we'll go through it. You decide to take $12 and invest it in a mutual fund, the value of your money for each year shown in the table. Here's our table, value of the investment, year, value of the investment. Let's read one. In this sequence, is this sequence arithmetic, geometric, or neither? Explain why in one sentence. So let's look back up at the table, and we're going to have to do a little bit of math. We're actually going to look at this second column, the y value column. If it's arithmetic, we're going to have a common difference. I always like to check for that first. So what we're going to have to do is think about what we can add to 12 to get to 19, and that's going to be plus 7. What to add to 19 to get to 26 plus 7. 26 to 33 plus 7, and as you can see, this is going to be plus 7 all the way down. This number is the same every time, therefore we have determined it was arithmetic. If it wasn't, we would have to check for geometric, but we're pretty good. So this is arithmetic because we have a common difference where each consecutive term is added by 7, or 7 is added to each consecutive term. So let's write that. We have arithmetic. Let's circle one. We have a common ratio. Oops, sorry. I was just doing geometric. Common difference. Where each consecutive term has been added by 7, or has been increased by 7. Let's write that. Increased by 7. That looks a little bit better. We have a common difference where each consecutive term has been increased by 7. Next, write the recursive rule for the sequence. So this is the recursive rule for arithmetic sequence. A sub n equals a sub n minus 1 plus our common difference. We can also have minus, because remember we can be subtracting. So this one right now, we are going to be using the plus because we're actually adding the 7 to each one. So a sub n equals a sub n minus 1 plus 7. This is going to represent our previous term. We're not sure what that nth term is. So let's go on. I'm sure we're going to be using this recursive rule for the next question. So let's read the next question. After 8 years, your investment will be worth $68. What will your investment be worth next year? Here's that keyword for next year. That means you're going to use this recursive rule. So let's write the recursive rule. A sub n equals a sub n minus 1 plus 7. After 8 years, so we're looking for that next, so we're looking for that 9th year, equals. We have 68, that was the previous amount, so that's what's going to be substituted in for a sub n minus 1 plus 7. So a sub 9, which is our 9th year, is going to be worth $75. Excellent. Turning the paper over, let's read what it says for number 4. Number 4 reads, write the explicit rule for this sequence. Writing down the actual just explicit rule, it's a sub n, a sub 1, plus or minus, remember, our common difference, times n minus 1. A sub n equals. Now a sub 1, let's remember, a sub 1 is our y value when x equals 1. So we have to go back to our table and look to see what our y value is when x equals 1. So here's our x column, or year. So here's 1. So let's look over and we see that it's 19. So flipping that page back over, we're going to have a sub 1, which we just found was 19. We are adding, because we have been adding 7 times n minus 1. Here is your explicit rule. I'm sure we're going to use it in the next problem, so let's read the next problem. Use your explicit rule to find the value of your investment after 75 years. So we have A sub 75, because that's the year we're looking for, equals 19 plus 7 times 75 minus 1. Now we have to evaluate this side. So A sub 75 equals 19 plus 7 times 74. Just did that by subtraction. We now have to do order of operations, which means we have to multiply now. A sub 75 equals 19 plus 7 times 74 is going to give us 518. And lastly, we're going to do that addition. 19 plus 518 is going to give us an amount of $537. I hope this helped. Good luck, and I'll talk to you guys soon.